So this video moves on to the next part of chapter 4, where we're going to start really diving into the 6 trig functions and their ratios. As a reminder, we just want to talk about that when something is in standard position, it means that one ray is along the positive x-axis, so it starts here, and then the other extends into the first quadrant. Okay, so if it's in standard position, it means it's in the first quadrant, and it's an acute angle, so 90 degrees. So we're going to start by talking about 6 trig ratios of a right triangle in quadrant 1, so in standard position. Today we will look at these 6 trig functions as a ratio of 2 sides of a triangle. Hopefully you remember hearing SOHCAHTOA from the past, and that's really what we're looking at today. So if we think about SOHCAHTOA, the SO stands for sine of theta equals opposite over hypotenuse. The ka part of SOHCAHTOA is that the cosine of theta equals the adjacent over hypotenuse. And you can see that we've highlighted those letters within. And the tangent of theta is the TOA part, which means tangent of theta equals opposite over adjacent. Now this chapter we did also start talking about cosecant, secant, and cotangent, the reciprocal functions. We learned that sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. So the one thing we can learn from that is that the cosecant, since it's the reciprocal of the sine, is instead of opposite over hypotenuse, it's hypotenuse over opposite. Secant, because it goes with cosine, instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And tangent and cotangent, since tangent is opposite over adjacent, cotangent is adjacent over opposite. Just a reminder of a right triangle. Okay, so anytime I have a right triangle, whatever angle that I'm referring to, so if this is my theta, the opposite is if I draw an arrow straight across it, that's the side opposite. The adjacent is the second side touching the angle, or the leg touching the angle we're talking about, and the hypotenuse is always across from the right angle. This note over here says if theta is at angle B, so if all of a sudden we call this angle, let's call it alpha, the opposite would be this one now. So it switches the opposite and adjacent if we talk about the other angle. Okay, so let's look at some examples of the type of stuff we're going to do today. So here's our first one. If I give you that sine of theta equals 5 over 6, we need to find the other 5 trig ratios. And remember, right now we're talking about angles in standard position, which means it's in the first one. Okay? What that means is I'm going to start by drawing a triangle in quadrant 1. This is the theta that sine of theta is referring to. Remember, sine is the SO part, which means that the sine of theta equals the opposite over hypotenuse. Well, from this side is the opposite, this side is the hypotenuse. So since the 5 is on top, that is the length of the opposite side. 6 is on bottom, so that is the length of the hypotenuse. So given the trig function, we should be able to label 2 sides of the triangle. That's what I've done in step 2 here. Now, finding the missing side length. If we're talking about right triangles, and if I know 2 sides of a right triangle, hopefully you remember the Pythagorean theorem to solve the third. So I'm going to do a squared plus b squared equals c squared. I need to find side x. Now remember that it's the hypotenuse that has to be the thing by itself. So it's going to be 6 squared over here. The a and b don't matter, so I have 5 squared plus x squared. So I can subtract. So I get 25 plus x squared equals 36. Subtract 25, I get x squared equals 11. And then we square root. Technically, when we square root, we get positive and negative, but since we're talking length, it's going to be positive. So I get square root of 11. Now it says find the other 5 trig functions. So we know sine, we're given is 5, 6. I usually write them all down. So sine of, come on. All right. Try again. Here we go. Sorry about that. So if I have sine of theta equals 5 over 6, because that's what they give me, cosine of theta is adjacent over hypotenuse. So that's the root 11 over 6, the hypotenuse. And then tangent of theta equals opposite over adjacent, which gives me 5 over root 11. But remember, we're never going to leave radicals in our denominator. I'm going to multiply the top and bottom by root 11. I get 5 root 11 over 11. The other three, though, are the reciprocal functions. So I go from sine to cosecant theta then. And I don't look back at the triangle. I just take the reciprocal of my answer there. So it was 5/6, so now it's 6/5. Cosine goes with secant. So it's going to start as 6 over root 11. But then again, I would multiply the top and bottom by root 11 over root 11. I get 6 root 11 over 11. And then finally, cotangent theta. I'm going to go back to the beginning where it's 5 over root 11, and then it's just root 11 over 5. So this is what I would have as my 6 answers. Now, sometimes depending on which answer key you're looking at, they may have decimals instead of radicals. I tend to leave my radicals, but I am totally fine either way. You can do whatever you want. Okay? All right, so that's the first one. Let's look at another example. Theta equals 12 over 13. Says assuming that theta is an acute angle in quadrant 1, evaluate the other 5. So once again, draw my triangle in quadrant 1. This is my theta. Tangent is opposite over adjacent. The opposite is 12, the adjacent is 13. And once again, I'm going to need to solve for the missing side. In this case is the hypotenuse. So I do Pythagorean theorem, a squared plus b squared equals c squared. My a and b are the 13 and the 12. So 13 squared plus 12 squared equals c squared. I get square root that, and I get that x. I guess it's green x. X is the square root of 313. Okay, so I, again, could turn that to a decimal. I'm just going to leave it as a radical. So I usually go through and find all 6. So sine of theta is the opposite over hypotenuse. So it's 12 over root 13. Multiply the top and bottom by root 313, and I get 12 root 313 over 313. It's an ugly answer, but it's an answer. Cosine of theta would be the adjacent, so 13 over root 313. Multiply top and bottom by root 313. I get 13 root 313 over 313. Tangent they gave me, so it's just 12 over 13. And then I go through and I find the reciprocal. Sine goes with cosecant. I go back to the beginning before I simplified, and I just switch it. So 13 is on top over 12. Secant of theta, again, I would switch it so that I have the root 313 over 13. And finally, cotangent theta, 12 13 flips to 13 over 12. So those would be the 6 trig functions. They gave me one. I found the other. Do me a favor and pause the video and do guided practice number 12. And once you have finished that, go ahead and play this to make sure you got it. So for guided practice number 12, again, it says in quadrant 1, so I'm going to draw quadrant 1, a triangle. Now for me, I don't like working with secant, so I'm right away just going to say that if secant 17 over 5, then I know cosine is 5 over 17. So I already know 2 out of the 5 that I need to find. But then cosine is adjacent, which would be this side, over hypotenuse, which is this side. Find the third side. I need to do a squared plus b squared equals c squared. 5 squared plus x squared equals 7 squared. When I simplified that, I got square root of 264. And I actually chose to play the friends game. And I got it to be x equals 66. You do not have to do that. You could have just turned it into a decimal, which is 16.25. I'll do the rest of the problem with the 16.25, but if you did it with the radicals, that's great as well. Now that I have all these labeled, I'm going to find the sine of theta, which is opposite. Sorry about that again. 16.25 over 17. And again, we already found cosine and secant, so the only one I need to find now is tangent of theta, which is opposite over adjacent, so 16.25 0.25. Then I find the reciprocal ones. Sine goes with cosecant of theta, so I'm going to flip these for that one. I get 17 over 16.25, and tangent goes with cosecant. So I'd get 5 over 16.25. In these cases, it would probably be best, since I left them like this, to type them in as a decimal. When I type these in, I got 0.956. 16 divided by 0.25. So for tangent, I got 3.25. Cosecant, I got 1.05. And for cotangent, I got 0.12. Okay. So I'm going to pause there. This is the first part of what we need to be able to do for assignment 5, but I'm going to make a bunch of smaller videos. Stop video 1 and begin video 2.